to take off also. So that today, the emissions from burning fossil fuels are nearing 7 billion metric tons of carbon per year. So this is the reason why carbon dioxide is increasing in the atmosphere, and this is the issue that we're dealing with. Now, as we try to project what will happen in the future, we need to project what the emissions of carbon dioxide will be in the future. Now, this is a very busy diagram here, but I just want to make a couple of points about it. One point is that some of these scenarios, which have been put together by engineers and economists and social scientists trying to project energy use into the future, assume that population will grow as rapidly as it's growing now, and that fossil fuels will be the major source of energy. If that's the case, then carbon dioxide emissions will rise to 25 or 30 billion tons a year by the end of the 21st century. Some of the other scenarios assume that technology may develop more rapidly. Those are the ones that sort of curve downward towards the end. That's the introduction of new sources of energy. Some of them may assume that population will grow more slowly. There's also different assumptions about how readily different societies share technology with one another. But no matter which trajectory we're on, the amount of carbon dioxide in the atmosphere is going to go up. Now, this may seem counterintuitive. If the amounts of emissions go down, why are the amounts in the atmosphere going up? Think of the atmosphere as a big bathtub. When we burn fossil fuels, that's like the faucet being turned on and water pouring into the bathtub. But the bathtub doesn't have a very big drain. The natural processes that remove carbon dioxide from the atmosphere are very slow. So they can only remove a tiny fraction of the emissions of carbon dioxide. So even if the emissions go down, the carbon dioxide levels will go up. The real question is, are they going to go up so rapidly that by the end of this century, they're 3 or 4 times what they were before the Industrial Revolution? Or can we devise a scenario in which they level off at a range which will still produce some changes in climate, but that those changes in climate will not be as severe? Now, we take these scenarios and put them into computer models of the climate. That's what I do. That's my specialty. And so I'm about to show you a little video here from a model that was run when Rabbi Milstein introduced me. He did use the abbreviation for National Oceanic and Atmospheric Administration Geophysical Fluid Dynamics Laboratory. So this is my old lab. It was really great when I used to be on the softball team and the other guys would ask us what GFDL stood for. Invariably, they all regretted having asked us once they heard the answer. But my colleagues down there have run this model. So here's a map of the Earth. The color scheme is at the bottom. Warm colors are above late 20th century temperatures. Blue colors are below late 20th century temperatures. And as I start this, you'll watch the years clicking by in the upper right. That's interesting. Here we go. I'll run it again. The years clicking by in the upper right, you'll see these patches of blue and yellow come and go. That's just the normal variations of the weather. But as we go farther into the 21st century, you'll notice that we're seeing less and less blue and more of the yellow, red, and brown. And now we're getting into the latter part of the 20th century. You can see that the continents warm up more rapidly than the ocean. The Arctic region tends to warm up more rapidly than the Antarctic region. And by the end of the 21st century, we see a much warmer world. I'll run it again. Take a look at it again. Imagine you're looking, here's New Jersey, and sometimes it's blue, so it's cold. Sometimes it's yellow, so it's warm. But gradually, as we go forward in time, we see less and less blue showing up, especially over the land, and more of the yellow and brown. Now, this is for one particular scenario that's more or less in the middle of that range that I showed you. So you could imagine stronger warming in some of the warmer scenarios and maybe a little bit less warming in some of the other scenarios. But in any event, there is going to be warming, and that warming is going to be substantial. That warming will have a variety of impacts on our planet and on our society. Those will include impacts on health, agriculture, forests, water resources, coastal areas, and species and natural areas. I'd like to talk about a few of the impacts that may be especially close to home for us here in New Jersey because of the characteristics of our climate and of where we're located. New Jersey is a coastal state. This is a shot of Northern Ocean County. This is, I think, Ocean Beach, about halfway between Point Pleasant and Seaside Heights. A lot of people on the beach. This is probably a weekend day in the summer. But I'm showing you this picture because there's not, well, there's two reasons why I'm showing you this picture. One is it just screams out the New Jersey shore because of the high population density, how close together the houses are. The other thing is that virtually no place in this picture is more than about 4 or 5 feet above sea level. So rising sea levels, which will happen as the world warms, will have an impact on New Jersey. Now, why does sea level rise in a warming world? Well, if I passed around a quiz, I'm a professor, I do that sometimes, and asked you what the reason was, you'd say, oh, that's easy, it's because the ice is melting in the polar regions. And you'd be right, that's one of the reasons. But there's another equally important reason that we often forget, and that is that when water is warmed, it takes up more space than it does when it's cold. The density of warm water is lower than the density of cold water, so that means it takes up more space. So even without adding to the amount of water in the ocean, that water would take up more space. So there's really two things happening. Ice is melting and water is growing. It's becoming less dense. And so when we look at the record of sea level at Atlantic City, we see that sea level has risen by a little more than 0.3 of a meter, or just about 1 foot, since the records began in 1912. That sea level rise of roughly 0.4 meters per century is a combination of the global sea level rise that's coming about because the world is warming, and the fact that the land in New Jersey is sinking. Now, a geologist could probably explain that better than I can. I can explain it a little bit. But suffice it to say that this sinking of the land is going to continue. So any sea level rise we see as a result of global warming is going to be superimposed on the sea level rise that occurs